Alright, ladies and gentlemen, right now what we're going to do, we're going to go do a couple problems of 0, 1.5 HW1 solving equations, which is the two-step equations as we discussed in class. Now if we look at our equation that's given to us, we notice we have a 6x plus 17 equals 62. Now, the first term is 6x. It has both a 6 and it also has a variable x. Our goal is to get the x all by itself. The plus 17, notice the 17 does not have an x. So these two terms are different. They're not of alike. They're not the same. And the 62, that term kind of looks like the second term, except of course they're two different numbers. But what's similar to both of these terms is that they both don't have an x. So they could be combined in the future, as we're going to go see. So here's our problem. 6x plus 17 equals 62. We're going to use our inverse operations to get x all by itself. So the opposite, or inverse operation of positive 17, is minus 17. So we subtract 17 from both sides of the equation. From both sides of the equation. When we do that, we get 6x equals, because the positive 17 and the minus 17 cancel out. And then we have 62 minus 17, which is 45. We just simplified things down. We rewrote it. So I write sim. The next step, well, remember, there's an imaginary multiplication sign in between the 6 and the x. So the inverse operation of times 6 is divide by 6. So we're going to divide by 6 to both sides of the equation. So to divide by 6 to both sides of the equation. 6 divided by 6 gets us 1, aka just x. And then 45 divided by 6 gets you 7.5. And that's our solution. Notice, we want to make sure we read those directions. The directions say, isolate the variable in the following equations. Round your answers to the nearest tenth. Example, 6.78 rounds to 6.8 when you round it to the nearest tenth. The nearest tenth is the place to the right of the decimal. So if we had 7.54, we know we will get rid of that 4, because that's in the hundredths place, because it's 4 below, you let it go. If our answer turned out to be 7.58, we look to that 8. Since it's 5 or higher, we would then add 1 to that 5, and it would be 7.6 as an answer. But our numbers turned out really nice. 45 divided by 6 turns out to be 7.5 even. It's exactly that. Which, that would be our answer for problem number 1. Next, we'll do problem number 2. Now the next problem, problem number 2, we have 5x minus 14 equals 57. Our goal is to get x all by itself. Now, this is given to us. So we write given right next to it. Now you might be asking yourself what's the purpose of knowing how to use inverse operations? But you're going to find out with the part material. It's going to be very, very, very helpful knowing your inverse operations when you have to isolate certain variables or certain symbols to get them all by itself on the equal signs when to solve the equations that they're asking for. So we have to know the inverse operations with the numbers first before we start playing with tons and tons of letters, which will gradually build up in our class to get tougher and tougher. They get you more prepared for the part material. So now, back to problem number 2. We have 5x minus 14 equals 57. How do we go about doing this? Well, we use our inverse operations. 5x minus 14. We know we can move that 14 to the other side. So we add 14 to both sides of the equation. Add 14 to both sides. When we do that, we get 5x equals 71. I just simplified. Wrote it out nice and pretty. Now 5 times x, well, we know there's an imaginary times sign. So then we divide by 5 to both sides. 5 divided by 5 gets us 1, so it's just an x, because there's an x right there. Carry down the equal sign. 71 divided by 5. We put that into our calculator, and we get ourselves 14.2. And that's our answer. Let's make sure we write all our work down. Here on the side, we divide by 5 over here. And then we have our solution. That's the answer to problem number 2. And how you go about solving these. Next up here is problem number 3, which says negative 4x plus 19 equals 61. Now, once again, our goal is to get x all by itself. We're going to use inverse operations. This is our given. We notice we have to move that 19 over to the other side, so we subtract 19 from both sides. From both sides. So we have a negative 4x, positive 19, negative 19, they cancel each other out. So we don't write anything. Carry down our equal sign. 61 minus 19 gets us 42. That's a times in between the negative 4 and the x. So we divide by negative 4. Divide by negative 4. Negative 4 divided by negative 4 gets you just 1x, so we have x equals. And then we type into our calculator. 42 divided by negative 4. And we get ourselves negative 10.5. And we're going to finish up our work. Over here on the side, we have simplify, then divide by negative 4 to both sides. And this is our solution. X equals negative 10.5. And that's problem number 3. Next up, we'll do problem number 4. Alright, so problem number 4, we have negative 7x minus 12 equals 19. So, we're going to crunch it out and get x all by itself. Just like what we've been doing. We got to move that negative 12 to the other side. We do that by inverse operations. Add 12 to both sides. Negative 7x. Negative 12 plus 12 is 0, so we don't write anything there. Carry down our equal sign. 19 plus 12 gets you 31. We then divide by negative 7 to both sides. And we're going to get x equals. Well, we type that into our calculator. And we're going to get x equals negative 4.428. Dot, dot, dot. Now, in the directions they say round to the nearest tenth. So it's going to be x equals negative 4.4. Let's recap what we did. We added 12 to both sides. We simplified. We then divided by 7. Sorry, divided by negative 7. Then we got our solution. And we made sure we rounded it, just like the directions say, to x equals negative 4.4. That's problem number 4. Next we'll do problem number 5.